Welcome into topic 2, video 2, right? So we will be jumping into the equation of a circle. And we're actually going to derive it from a triangle. Right, so if we remember in our last video, we went through how we took a triangle and derived the distance formula. And so we're going to do something similar, but as a reminder, what did we use? We used the Pythagorean theorem. Right, so if we had a right triangle, we'll say A, B, and C, we know that A squared plus B squared is equal to C squared, right? This is coming from the Pythagorean theorem. Now we're going to take the same idea and draw a circle and try to derive the equation of a circle. Right, so let's see if I can do my best attempt at drawing a big coordinate system here. It's not bad. We've seen worse. Okay. And now my attempt at a circle. I'll draw it there. You guys, that might be my best circle yet. All right, put a dot in the middle. Okay. Now the dot in the middle represents the center of the circle, and we're going to call this HK. And we'll make like a little legend over here so we don't forget. HK is the center. And I'm going to start drawing a bunch of lines everywhere, so hopefully we follow. Right, now HK is just what? It's a coordinate, right? It's a coordinate inside the XY plane. And so what I want to recognize is, right, the X coordinate here is H. So we're just going to draw a line straight down, dotted line, straight down because it has this particular X value. And I'm going to draw a line straight over, right, because it has this particular Y value, right? The K is the Y value. The H is the X value, right? Nothing too crazy. Now what I also want to do is I want us to pick some arbitrary point on the circle. Right? Some arbitrary point on the circle. You can pick it wherever you want. I'm going to pick one right here. And I'm just going to call it XY, right? Because you could have picked any XY. I picked this specific XY. And I'm just going to connect the center to that point. Right, or at least I'm going to try. Oh, I missed slightly. Pretend it's over here. Okay? Now, the distance from the center to the circle has a name. We're going to denote it as R, but it's called the radius, right? And it's just going to be the distance from the center of the circle to the circle itself. Radius. Okay? And now, along with this XY point, right, it also has an XY value. And I know I'm over embellishing here, but just so we see, I'm going to also draw from this dot a line straight down, right, to show that this X value, right, is the same all the way straight down. Right? Now, hopefully this triangle is starting to come into play how we see it here. I'm going to draw the Y value straight over. Okay, so again, now we end up with another triangle, and this is indeed a right triangle. And now let's just try to find the length of the sides of the triangle. So let's find this length, right? We'll notice here this is X and this is H, right? So if I want to find the distance between X and H, I'm just going to subtract, right? So this distance here is just X minus H. And I'm going to do the same thing for the Y's. What's the distance between Y and K? It's just going to be Y minus K, right? That's going to be this distance here, and this is going to be this distance here. And now using this, right, I have all the sides of my triangle. I can go back to the Pythagorean theorem, right? And now what does the Pythagorean theorem say? Well, let's take our bottom side here first. X minus H, which is our A, and we're going to square it, plus y minus k, right? Which is just our b, and it's equal to r squared. And guess what we have here? We have the equation to our circle, right? Where hk, right? This point is just our center. And the r here, right, is our radius squared. And I'll say squared. Right, so if I gave you some hk value that represented the center of our circle, and I gave you some r value that represents the radius, you could give me the equation of the circle, right? That's the whole idea. And we're going to go through a few examples coming up here, but we'll take a short break, stretch it out. I will see you in the next part of the video. Welcome back. We're going to go through a few examples here. Okay, so I'm going to write it out. I think we're going to go through 3. So we'll put 1 over here. We'll say we're going to find the equation. So I'm going to give you some hk. I'm just going to say, what is equation, I'm going to abbreviate here, of circle, and I'm going to give you your hk. Let's put this at -1, 2. Sorry, I'll move out of the way, and we'll say r is equal to, let's do 7. All right, so pause the video, see if we can go through it. So again, we're going to need the equation of our circle, right, which we derived in our last part of our video. Okay, so what is the equation? Well, we know that it's going to be x. Now, it's always a minus sign here, right? And that's derived from the triangle. So x minus a -1. So x minus a -1, we'll just write it all the way out for right now, squared, plus y minus 2 squared is going to be equal to r squared. And so if we want to write this all the way out, right, simplify it, we don't want a double negative, so this becomes an x plus 1 squared plus y minus 2 squared is equal to 49. Right, so that is our final answer. And we should be able to go back and forth. Right? I'm not going to write down an example of this. Maybe I'll do a few in class. But we should know that if I give you this, right, you should be able to tell me what hk is, the center, and you should also be able to tell me what the radius is, going the other way. Right? So we should be able to go back and forth doing this problem. The other one that I want to do that's a little bit trickier, let's draw a line. And I'll say, if I give us x squared plus, let's say, 8x plus y squared, let's do minus 6y is equal to 14. What is the equation of the circle, right? So we want it in the form of this, right? We want it in the form of this. All right, that's what we're looking for. So the question is, how do we do this, right? Because this doesn't look to be in the correct form as is. Well, this process, right, and we'll do one in class too, but this is known as completing the square, right? I need to complete the square. But I need to do 2 separate pieces. So I'm going to do one at a time. Right, so first, let's only deal with the x's. Right, so if I have x squared plus 8x, what do I need to have here to make this a perfect square? Right, well, this would be a 4x plus 4x, right, or a 4 and a 4, right? So to complete the square, this would have to be a 16. And I'm going to pause, right? All right, so I've added this arbitrary 16. I'm going to put equals 14 over here. I added 16 out of nowhere, right? And again, it will make sense when I complete the square, right, which is going to go backwards. This 16 is going to help me finish this process. But I can't just add an arbitrary 16 to the left side without also doing it to the right side. Okay? So I've added the 16. The reason why I've added the 16 is because now I can go backwards and write this as x plus 4 squared, right? So now it has this similar form, right? I know it doesn't have the negative sign, but that's okay. Right, and you can double check, right? X, right? What does this mean? I'll write this down here. We have x plus 4 squared, right? This is the same as x plus 4 times x plus 4, which would give us, right, if we factor everything out, we have x squared, we have 4x plus a 4x is equal to 16, right? Which simplify, or not equals 16, plus 16, sorry, plus 16. Right, and we can see that this is the same, right? X squared, 4x and a 4x, 8x, 16 and a 16, right? So these are indeed equivalent, and it's in the form that we want, right? So this process is called completing the square. Now I want to repeat that same idea here with the y's, right? So if I have plus y squared minus 6y, so essentially what's happening is I took my 8x, right? I really just stole the coefficient. I divided it by 2, right? That was the number that we needed, and then I squared it, right? So 8 divided by 2 gave me 4, and then I squared it, which gave me the 16. That's what allowed me to complete this square. Same thing here. Negative 6 divided by 2 is going to be negative 3. If we square negative 3, we get a plus 9. And again, though, if I add 9 to the left-hand side, I can't just add an arbitrary 9 without doing it to the right-hand side. And now we can simplify this. This will end up being y minus 3 squared is equal to 14 plus 16, 30, plus 9, 39. And we have our equation of our circle, right? So the process that we need to be familiar with is completing the square. Now again, I'm only doing one example of this. I will do several more in class, right? I know this process might not seem as easy as I made it look. If it did, great, that's awesome. If not, we'll do more in class, right? In this case, again, we can say what HK is, right? The center of the circle, right? Again, it's always a minus sign, so the fact that I have a positive means that this is going to be a minus 4 for my x value, and my y is going to be a positive 3. And I also know my radius, right? This is my r squared, which means my radius would be the square root of 39. Right, so I know this one easier than the right-hand side. The process that maybe we struggled with a little bit, that we need to investigate a little bit more, is completing the square. I'll go into further explanation in class, but if this video helped, great. Even if we only picked up 50%, right? At least we got a head start of what before I talk in class, right? So if you have any questions, come to class, ask away. Other than that, that's all I got for you. See you guys.